Hello physics. We are now starting our lab on friction. This is our handout on it. And we're going to study about the different kinds of friction. We've talked about static friction and kinetic friction. Which one's stronger? As you know, we've said that static friction is stronger. So we're going to do a little lab activity here using these blocks. We're also going to experiment with how much mass makes a difference, whether a lot of mass makes a difference in the friction, or whether the surface, contact surface, makes a difference on edge or flat. All right, let's get started. All right, so our first instruction says using a spring scale, so here's our spring scale, we're going to pull a single block laying flat across the surface of the table. Record the amount of force required. So we're going to take this block, we're going to lay it flat on the table, and put the string around it and try to get it to hang on. This is where having a lab partner is really nice. So we need you here. All right, so I'm going to try to keep this moving at a constant speed across the table and see how much force it says here on the spring scale, which you can see is bouncing. So I'm going to get sort of a mental estimate. And we're going to say about 250. So I'm going to write down for my force exerted is going to be about 250. This scale says grams on it. And for now, we're just going to leave it in grams, even though we know that we should use newtons because we're just going to have the same ratio. All right, so that was with one block on it. All right, so now we're going to do the same thing, but with two blocks on it. So I'm going to try to pull it at a constant speed. And we are around 525. Obviously, it's bouncing around 525 grams. All right, we'll slide back here, and we're going to do 3 blocks. All right. Here we go. And we're right about, roughly 700. And we'll go back here and we'll do 4 blocks and see what we get for our force required. Here we go. Boy, that one's a hard one to read. I'm going to do it again. Too much static friction messing me up here. Oh, I'm going to do it again. I'm going to say around 1,300. 1,300 grams. All right, let's go to the next one. So we've done the first trial with the blocks all on the longest edge. Now we're going to put it on the shortest edge. And so that's what's going to go into this next row here. And I'm going to pull it using the spring, and we're going to compare what the force is required to pull this at a constant speed. And for our first one, I get 250 grams. All right. Now we're going to do it again. This time we're going to put 2 blocks on the same surface area. And let's see where we're getting here. Okay, on this one I get about 600. All right, this is a very inexact science, so we're just going to get some good approximations because I don't pull very consistently. All right, here we go. All right, we're going to call that one about 900, which is more than I was expecting. And then we'll put on 3 here, or 4 altogether. All right. Okay, we'll call this one about 1,300. All right, and part of the reason why we did that is because we're comparing whether or not the amount of surface area makes a difference. Small surface or big surface. All right, we'll move on to the next one. Okay. So now we're going to do the third trial. This is what we're going to do on carpet. So we're going to do a different surface instead of the countertop. We're going to do the carpet, and we're going to pull it with 1, 2, 3, and 4 blocks. So let's get started. Here's one block laying flat. And really nice there at 200 grams on our spring scale. Let's put a second block on there, pull it across really nicely at about 400. And then we're going to put 3 blocks right about 600. And 4 blocks. 4 blocks. Oh, about 750 there. Okay. We'll pause there and get on the next one. All right. So here we are. We're going to do our 4th trial, this time with the blocks on edge, and we'll see what force it requires to pull it on edge. So I would say we've got about 175 there. Let's slide it back, put 2 blocks on there. We're right at about 350. And about 550. And about 700. All right, that completes the first side of our lab sheet. Now we're going to go to the back side. All right, so now we're going to look at static friction. So we're going to look at what force it takes to get it started. So we're going to zoom in on this, and you're going to watch as we add pull until it starts to move. So what's the highest force registered before it starts to slide? Did you see it? Just right over 800. So let's say that that was about 850. That's the max force exerted before sliding, 850 grams. All right, this force exerted to maintain a constant speed we can get from the other side here, which was 525 grams, okay? Now we're gonna go do the same thing over on the carpet. So now we're gonna test the coefficient of static friction on the carpet. And you'll notice that it's not nearly so noticeable as it is on the tabletop because it really slides so easy on the carpet. And this is a little bit of a crude way to measure, so our data is going to be perfect. But if you can zoom in on the spring scale here, I'm going to just add force until it starts to slide, and you can see it drop down there. So we got up to about 450 or so before it started to slide. So on your lab paper here, we're going to put 450 here. You can get the 400 from the other side of your data table. And we'll talk about getting some more data for the rest of it. Our next step is to find the mass of the blocks. And that's what you're going to use to do the rest of your calculations. So to find the mass of the blocks, well, we're going to have to take our piece of wood and put on a scale. Now this is actually pretty heavy, so we don't usually have lab scales that measure things that are this heavy. So this scale can't handle it, so I'm going to have to help it. We're going to use a balance here, and I'm going to put on weights here until it tips. These are 200 grams a piece, and that's just barely at 100. So I'm going to, oh, I know my problem. I put this backwards. And so this would be 200. So that would be, got to get it in the notch there, 2, 4, 600, 710, and then, so about 716 grams. 716 grams. And of course, that's the same for both of those boxes. Then, in order to do the calculation of the coefficient of friction, you're going to have to convert grams into newtons. So remember to move the decimal, turn that into kilograms, and then multiply times the acceleration due to gravity before you move on and do the rest of your calculations. All right, let's talk about the questions. So we have two questions. What factors did play a role in the amount of friction? So I'll give you some hints as to what factors to think about. One would be, did the number of blocks play a difference in how much friction there was? You're going to use your data on your data table here to figure out, well, based on your data, what made a difference? Was it the mass of the blocks? Was it whether the block was on an edge or if it was flat? Did the amount of surface that came in contact, did the surface contact make a difference? Did the surfaces make a difference? Was it the countertop and the carpet? Does that play a role in the friction? And so, by the same token, what factors might be thought to play a role but didn't? So maybe one of these we thought, oh yeah, it should make a difference, but it actually didn't make a difference. So those are the questions you need to answer. And of course, don't forget to write a conclusion that summarizes the things that we were demonstrating, learning, and illustrating in this lab. All right, so do your lab write-up as we normally do and turn it in.